Good morning, good afternoon, good evening, depending where you're joining us from. We are here for another CTF reveal. This is number 19. Today it's an interesting lesson. It's about remote command execution, right?
Yep.
And it's yeah, this is another one of those things that happens in the wild, and we're here to teach developers how to spot this, and also how to fix this to make sure this doesn't happen. So Wizer CTF is part of Wizer Secure Code Training. This is the public version where you can go to wizer-ctf.com and you can play those CTFs. This is a retired one, and every week we release, every 2 weeks we'll release a new one. So we also have live ones. With that said, I'll let Itzik introduce the problem and the solution and the key takeaways. So Itzik, the floor is yours.
Thank you, Gabby. So this is a calculator, and we're required to read the content of the OS passwd file as we do in the other ones. There's only one endpoint here. It does calc. Very much like eval, a little different. It actually takes our argument and actually runs the function constructor and returns the value of calc. In addition, however, the developer chose to add the require so that things like math, require math.js can be used in the calculator. So we can do things like square root and other things. So for example, something like this, if the calculation uses argument 0, which is the require, then require math.js and use square root, I can run that and get the value, which is 14, square root of 196.
Perfect. So this is the problem. Let's see how you hack this, and then we're going to talk about some key takeaways. So what's the solution?
Right. So first of all, the vulnerability and the solution is that we're actually running code in the context of our code. The fact that it's a little more isolated than eval doesn't help much, because we are also sending the require argument here. So in order to solve it, we can exploit the require, the fact that require is being sent here, and you want to use one of the basic libraries that is called fs. So how do we do that? We can use argument 0, include the fs or require the fs, and then use a very simple file read command like read file sync, etc passwd, run it, and here you go. Just got the content of the file. Very easy.
Perfect. So why do you think people had a challenge with this? Like, what was the problem that they encountered? Because this is 2 papers, right? This is not a 1 paper. It looks very simple. So what's the trick here?
Yeah, so people first haven't noticed the require or didn't know how to use it. So when I send the require here without a name, I need to use argument 0, as you noticed. I don't have an argument name, so it's maybe less trivial. People don't understand the syntax and can't figure out how to use it, or never even notice that it's being used. So that was the main reason. The other reason maybe is that unlike eval, this is isolated.
Gotcha. Okay. So let's jump into the key takeaways. What can we learn from this, and what's the best practices for avoiding something like this?
Absolutely. So 3 main takeaways. First of all, eval, just like constructor of a function, are definitely out of the scope. We shouldn't use them. We should never use them, never consider using them. There's always better ways to do it. There are methods that allow us to run calculations, etc., etc. Definitely eval sounds like an escape path that is easy, but not a good one. The second takeaway is that sanitization is required. Here, if we're using eval, at a very minimum, we should state specifically what's valid and what's not valid. So if we would have kind of like provided some sort of a whitelist, this wouldn't have happened. We won't be able to use the read file or the fs. Okay, so sanitization. And lastly, we always should, even if we don't know of a remote code execution vulnerability in our code, we should never allow the process that runs the app to access things that it shouldn't. Like, for example, if the user here that runs the process wouldn't be able to read past WD file, we wouldn't be able to show the vulnerability here. So always limit the privileges to the bare minimum that the app needs in order to run.
Great. So this is the type of things that are also important in the design stage, right? So when we write the code, we have to think about those things. So we tend to think about functionality, right? In most cases when we design the code. But I think, what we are trying to do here is to make people think about the security implications, like you said, the access control, the scope, the sanitization, the type of functions they're using to achieve what they're trying to achieve, what's the most secure one. So all of those things are things that need to be done at the design stage, and that will make things way much easier later than trying to bring pen testers and hack the code and find all of those things. Because if you think about it in advance, you're basically you understand the root cause of those issues, and you're not dealing with patching it later.
Exactly. I think there's another tip here that I can use is if you do something that is very easy to do and provides a lot of power, you're probably doing something wrong. Because here we're using the JavaScript engine to run everything that the user might need. So based on user input, the JavaScript engine runs everything. This means that the JavaScript engine is way more powerful than you want it to be. It can run other things that you never intended. So it's just like the template engine when there's SSTI vulnerabilities and running HTML that can cause XSS and other things. If you're doing something that is easy to do and provides a lot of power to the user, you're probably doing something wrong.
I love that. So be more specific. And again, guys, if you write secure code, in my opinion, it's higher quality code because you're more specific with what you're trying to achieve, and you're not sort of catching all type of just because you don't know how to do stuff doesn't mean that you have to go the easiest route. Better to look at the documentation, understand what you're doing, and be very, very specific. That leads to less bugs at the end of the day, which is also a more stable code.
Exactly.
Cool. So if any one of you want to try this out, you can go to wizer-ctf.com. You can then scroll back to challenge number 19. You would probably land, if you go to the wizer-ctf.com, let's go to the latest challenge, you'll probably land here. So these are the active challenges. So you can try and get into the leaderboard and solve them. And once they retire, we are basically doing this. We're also providing write-ups, and we're doing these short videos to explain how to solve them. And if you want to go back at the top left, you can just start scrolling back. And the purple ones, if you go more, the purple ones are the ones that are retired. So we still have a lot to do. There's like 30 something retired, and we're just number 19 right now. So you're going to be seeing us every week here doing at least one or two to catch up with this. So that's it. With that said, thank you very much. Hope you learned something. And thank you, Itzik, for writing these challenges and also explaining how to solve them. And well done to all the people that were able to even get into the leaderboard. It's not easy. So with that said, thank you very much, and see you next week. Bye-bye.